So now, how do we shrink these two special right triangles? Notice that we want each one to have a hypotenuse that's equal to 1. So let's start solving for that. Now normally I would write in pencil, but I want you guys to be able to see what I'm doing, so I'm going to start writing in pen. So we're going to make 2a equal to 1, and we're going to make a times the square root of 2 also equal to 1. So now, for the first one, we are going to solve for a. So now, if we know that 2a is equal to 1, we can determine that a is equal to 1/2. And now, if a is equal to 1/2, it follows that you can add 1/2 here times the square root of 3, or square root of 3 divided by 2. And also here, a is 1/2. So now we have derived that when the hypotenuse is 1, the side that is opposite 30 degrees is always half the hypotenuse, so this will be 1/2. And the side that is opposite 60 degrees will be the square root of 3 divided by 2. And this ratio holds no matter what the orientation of this triangle is. So now let's move on to the 45, 45, 90 triangle. So here, in order to solve for what a is in this case, we're going to make 1 is equal to a times the square root of 2. And now to solve for a, we divide both sides by the square root of 2. However, we like to rationalize our denominators, so I'm going to multiply both the top and the bottom by the square root of 2. Notice that by multiplying by the square root of 2 divided by the square root of 2, I'm simply multiplying by 1 because they simplify to be 1. So this is now the square root of 2 divided by 2. We can now take this information and add it here. The square root of 2 divided by 2 and the square root of 2 divided by 2. So now, when we've dilated that special right triangle, we now have that the hypotenuse is 1 and that the two sides of this equilateral right triangle are the square root of 2 divided by 2 and the square root of 2 divided by 2.